Hi guys, so it is Miss Nico here, and we are going to be doing our first distance learning new lesson for pre-algebra, and this one is going to be focused on probability and odds. Okay, so what I want you to actually do first is you're going to see that I filled out a bunch of definitions that go along with terms, so I want you to go ahead and pause this video, take some time, write down all those definitions, and then once you're ready to start going over them, after you've copied them all down, you'll press play again. So go ahead and pause right now. Okay, so hopefully you have now pressed play again because you are ready to start going over some of these. So I'm going to briefly just go over what all of these kind of mean, and then we will go from there. So term, possible outcomes, all of the possible outcomes. So let's say we're looking at the weather today. Your possible outcomes could be that it's sunny versus it being rainy, or it's snowing versus it raining. Okay, those are the total possible outcomes. Your sample space, that is the list of all the possible outcomes. So rain, snow, sun, wind, anything like that. Probability, that is the likelihood that an event will occur. So if you look outside, when I'm recording this right now, it's a beautiful sunny day. Hopefully it is when you are watching this video. So what is the likelihood that it will rain? It's probably pretty low. So the probability would maybe be that there is a 5% chance that it's going to rain. So favorable outcomes, that's the events you want to occur. So we would want it to be sunny today. That's the event that we want to see happen. What is the unfavorable outcomes? The unfavorable outcome would be that it rains today. That's what we don't want to occur. Okay? Now we talked about probability, and now we have something called odds. And the odds are the comparison of favorable to unfavorable events. So we looked at the favorable outcomes versus unfavorable outcomes. The odds compare those two numbers. So the chance that it's going to be sunny over the chance that it's not going to be sunny, which means that it's raining. Theoretical and experimental probability are the last two definitions that we are going to look at. Theoretical probability is the ratio of favorable outcomes to the total possible outcomes. Okay, so it's the favorable we want to have happen over the total possible outcomes. And theoretical probability is like existing in a perfect world. Okay, experimental probability is what actually happens. It's the number of times that you get a favorable outcome when you do an experiment, when you actually conduct an experiment. And sometimes that can be a little different than the theoretical because we're human. We might, flip a coin a little differently each time, and it won't always be a 50-50 shot that we get heads versus tails. So experimental probability goes into more of what happens when you actually conduct an experiment, what the probability is versus what it should be, which is the theoretical probability. Okay, so getting now into our notes again. So probability. Probability is, again, what we want to occur over our total. And probability is a number from 0 to 1, and it can be expressed as a fraction. Whoa, my pen doesn't want to write. There we go. As a fraction, a decimal, or a percent. So we can compare probability to benchmarks. And what I mean by benchmarks are numbers like 0, 1/2, and 1. And that can help us understand how likely an event is to occur. Okay, and that's what we are seeing right here. Okay, 0 being it's impossible, 1/2 being it's equally likely either way, and then 1 being that it is certain. So let's get into an example here. So it says a bag holds 8 pieces of paper numbered 1 to 8. So the first thing that I want us to do is make a list. 1, 2, 3, 4, 5, 6, 7, and 8. We're going to make a list 1 to 8 because that's how many pieces of paper there are. They're numbered 1 to 8. Nick chooses a piece of paper at random. What is the probability that Nick will choose a 4? So we want to know what is the probability that Nick is going to choose 4. Okay, so again, probability of him choosing 4 is what we want over the total. What we want is him to choose a 4. Well, how many times is there a 4 in these numbers? There's a 4 once. Okay, there's a 4 once. I know it's the number 4, but it's how many times does that number occur? It occurs once. And that's going to be over the total, and there is 8 total. So that means that our probability of Nick pulling out a piece of paper that has the number 4 on it is 1/8, 1/8. So if you go back and you look at this spectrum from impossible to certain, and you think about where 1/8 is, well, 1/8 is less than 1/2, so that means it would be unlikely. Okay, so now let's go down and let's look at number 2. Number 2 says a number cube with the numbers 1 through 6 is rolled. What is the theoretical probability of rolling a 3? First thing I want us to do again is list those out. You have a die, or a number cube, and you can get 1, 2, 3, 4, 5, or 6 when you roll it. What is the theoretical probability of rolling a 3? I want to know what is the probability of rolling a 3. And again, probability is what I want over my total. How many times does 3 occur? It occurs once. So that's what I want to have happen. Over my total, there are 6 total possible outcomes. Again, 1 is how many times what I want is occurring. I want it to be a 3. A 3 occurs 1 time. How many total options do I have? I have 6 total options. So my probability is 1/6. How likely is that? That's again unlikely because it is less than 1/2. It's not impossible because it's not 0, but it is unlikely. So then it says, what is the theoretical probability of rolling an even number? So now let's list these out again. 1, 2, 3, 4, 5, and 6. What is the theoretical probability of rolling an even number? Even number would be 2, 4, or 6. That occurs 1, 2, 3 times. So the probability is what I want over the total. That happens 3 times over my total, which is 6. 3 over 6 simplifies to 1/2. 1/2 means that it would be equally likely. That means that there is an equal chance of me rolling an even number versus not rolling an even number, which means I'd be rolling an odd. Okay, so that was probability. Now we're going to look at odds. Odds in favor of an event, odds in favor are what we want over what we don't want. Okay? In this case, and this is very important to remember, the total does not go on the bottom like probability. In probability, we put the total on the bottom. We're not doing that in odds. Okay? We're putting what we want over what we don't want. So if I added those together, I would get the total. And we're going to look at that in a little bit. Another thing that's important to remember with odds, they are written as a ratio a lot, something like 1 to 2. Okay, that's what odds look like a lot of the time. You can write it as a fraction, you can write it as a ratio. It does not necessarily matter. You'll probably see me writing it both ways at times. Now, the odds against an event happening, the odds against is what we don't want over what we want. So it just flips that fraction. Odds in favor, if it's in favor, it's what you want. That's favorable, it's what you want. That goes on top. Against, that's what you don't want. So then that's when that goes on top. So it just flips depending on which one it is asking you. So let's look at this example. It says, suppose you randomly choose one letter from A through J. So let's write those letters out. A, B, C, so we have all of our letters. It says find the odds in favor of choosing a vowel. So my vowels are A, E, I, O, and U, but O and U are not included in this. So again, odds are what you want over what you don't want. So what I want is the vowel. There are 3 vowels. Over what I don't want, 1, 2, 3, 4, 5, 6, 7. Over the 7 that are not a vowel. It's what I want over what I don't want. Okay? I want it to be a vowel. That means I don't want it to be a consonant or not a vowel. So the final way that I would write that is as a ratio 3 to 7. So the odds in favor of me choosing a vowel are 3 to 7. For every 3 vowels that I choose, I would get 7 consonants. Okay? If you added 3 and 7, you would get 10. And if you counted up the number of letters you have, you would notice you have 10 letters. So now we want to get the odds again. So we did odds in favor. Now we're doing odds against, choosing a C. So now odds against are what we don't want over what we want. Okay? What I don't want is to get a C. The odds against choosing a C. So what I don't want is anything other than C. So 1. If you look at over here, there's a lot of options. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are what I don't want over what I do want, which is getting a C. So that would be 1. The odds against choosing C is what you don't want versus what you want. Okay, that's the odds against me getting that. So then I would write that as 9 to 1. Last one here is odds in favor again of a consonant, not a vowel. So it's what we want over what we don't want. And the nice thing here is we actually already did the math for this up above. What's the odds in favor of getting a consonant? We know that there are 7 consonants over the 3 vowels that there are. So that would be 7 to 3. And if you notice, it's just the exact opposite of the odds in favor of choosing a vowel. Okay? Last thing we are going to look at is theoretical versus experimental probability. So a number cube with the numbers 1 through 6 is tossed 30 times. The results were recorded on this table. What is the experimental probability of tossing a 3? Okay, the experimental probability of tossing a 3. So you go ahead and you find on here all the times that you rolled a 3, and there are 6 of them. So 6 out of the 30 times that you rolled the dice, you got a 3. If you simplify that, that's 1 over 5, or you could write that as 20%. So that's the experimental probability. That's what you actually got when you tossed that die 30 times. Now let's look at the theoretical probability. In a perfect world, what should you have gotten for it? So if you look at that, if you rolled the die 30 times, 1, 2, 3, 4, 5, and 6 are your options. It wants to know what's the probability of you getting a 3. If I did that 30 times, it would be, what would that look like, right? You would roll that. It doesn't matter how many times I rolled the dice. Theoretically, every 1 out of 6 times, because there's 1 3 out of the 6 total options, I would be rolling a 3. It doesn't matter how many times I do it. In a perfect world, it would be 1 6. And that is roughly 17%. So then it says, how does this compare to the theoretical probability? The experimental is greater than the theoretical. So in practice, when you actually did it, you actually got a higher chance of it happening. Okay, so hopefully you guys are all good with those notes. We will have plenty of time for you to go over and ask me any questions that you might have. So now it is time. Take your time and then get ready to tune into the live session. Thanks.